We will now discuss the solution of a problem from the section Unit 1, that is sets, relations and functions. This question is about composition of functions and the greatest integer function. This question has appeared in the joint entrance examination main held on 25th June 2022 in the first shift. The given problem is, let f be a function from the set of real numbers into itself defined by f of x is equal to, in brackets, 2 into 1 minus x to the power of 25 by 2 into 2 plus x to the power of 25 whole to the power of 1 by 50. If the function g of x is equal to f of x plus f of x, then the greatest integer less than or equal to g of 1 is, we have a function f from the set of real numbers into itself defined like this, and g of x is given as f of x plus f of x. Then we have to find out g of 1. Then what is the greatest integer less than or equal to this g of 1 we have to find. We now discuss the solution of the problem in detail. We have the function f from R into R defined like this. Now we simplify this function. We will get inside the bracket, take the LCM in the first bracket, that is 2 minus x to the power of 25 by 2, 2 in the denominator, 2 in the numerator. They will cancel each other and you will get this is equal to 2 minus x to the power of 25 into 2 plus x to the power of 25 whole to the power of 1 by 50. Now it is of the form a minus b into a plus b, and that is equal to a square minus b square, that is 2 square minus x to the power of 25 square, that is x to the power of 50. That is, the answer is going to be 4 minus x to the power of 50 whole to the power of 1 by 50, that is f of x. Let's call this as the equation 1. We are given g of x is equal to f of x plus f of x, required to find the bracket g of 1, that is the greatest integer less than or equal to this number g of 1. We put x is equal to 1 in the above, that is in g of x. We get g of 1 is equal to f of 1 plus f of 1. Let's call this as the equation 2. And to compute g of 1, we first of all know what is f of 1. Now put x is equal to 1 in the equation 1, and wherever there is x, you just write 1. So the f of 1 is equal to 4 minus 1 power 50, that is 1, 4 minus 1, that is 3 to the power of 1 by 50. So f of 1 is 3 power 1 by 50. We continue in the next slide. That's what we have done so far. F of 1 is equal to 3 power 1 by 50. Now we find f of 1, that is f of 1 is 3 power 1 by 50, and go to the equation 1, and wherever there is x, substitute 3 power 1 by 50. then you will get 4 minus 3 power 1 by 50 whole power 50. Now 3 power 1 by 50 whole power 50 is 50 cancels, and it is 3 power 1, that is 3 only, and we will get f 4 minus 3 whole to the power of 1 by 50, that is 1 power 1 by 50, that is 1 only. So we got this one, f of 1. Now we go to g of 1, f of 1 plus f of 1. We know this is 1, and this inside one also is 1. So we will get this is equal to f of this is 1 plus this is 1. So f of 1 plus 1. So f of 1 value we know 3 power 1 by 50 plus 1. Agreed. So we want the bracket g of 1. So therefore that is equal to bracket 3 to the power of 1 by 50 plus 1. That is the greatest integer less than or equal to 3 power 1 by 50 plus 1. How much is that? And we recall a result on bracket functions, greatest integer function. So this is bracket x plus n. The greatest integer of x plus n is equal to bracket x plus n for all x belongs to R and for all n belongs to Z. Now, in our case, x is 3 power 1 by 50, that is the real number, plus 1, that is the integer. So, applying this one, we get the bracket of 3 to the power of 1 by 50 plus 1. Now, the bracket of 3 to the power of 1 by 50 is equal to 1. How it is, I will explain later after this slide. And so this is bracket 3 power 1 by 50 is 1. How it is, I will show you after this slide. Let's first of all take this as the result. That is bracket 3 to the power of 1 by 50 is equal to 1. That is the greatest integer less than or equal to 3 power 1 by 50 is 1. So this is 1 plus 1, that is 2. That is 2. So that is the answer for this question. The answer is g of 1, the bracket g of 1 is equal to 2. That is the greatest integer less than or equal to g of 1 is 2. That's your answer to this question. And this completes the discussion of the solution of the problem on composition of functions from Unit 1. But I have promised you that I will show you how this bracket of 3 power 1 by 50 is 1. I will do it by two methods. First we go to the first method. Now how do you show that bracket 3 to the power of 1 by 50 is 1? Now this is method 1. So in this I will use the binomial theorem for a rational index. That is 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus so on and so forth. Where x is any real number, n is a rational number we have considered, and that is why n into x, n into n minus 1 by 2 factorial into x square we have written plus so on and so forth. We have not written nc1 and nc2. Why? Because it is a rational index. N is a rational number, therefore we write like this only. Now take x is equal to 2, n is equal to 1 by 50. So you will get 1 plus 2 to the power of 1 by 50 is equal to, we approximate it by taking just two terms of the binomial expansion. That is 1 plus 1 by 50 into 2. That is 2 by 50. We write that as 4 by 100. So that is 1 plus 4 by 100 plus so on and so forth. That means we are approximating by taking just two terms of the expansion. It's only an approximation what we are considering. and this will be 1.04, approximately equal to 1.04. This is the approximate decimal expansion, decimal representation of 3 power 1 by 50. So it is approximately equal to this. So therefore 3 power 1 by 50 is approximately 1.04. So the greatest integer less than or equal to 3 power 1 by 50, that is the greatest integer less than or equal to 1.04 is 1 only. Therefore, bracket 3 to the power of 1 by 50 is equal to 1. So that is the method 1. We go to the method 2. Now, so why we are showing these things? Because in the examination, you are not allowed to use calculators. But however, you have to get the answers. So how do we get it? So these are the methods that you can follow in the examination hall. So because you don't have calculators, such kind of methods are required. Now this is the second method we concentrate. Now I want to prove that 1 less than 3 power 1 by 50 is less than 2 properly. That is 1 is strictly less than 3 power 1 by 50 strictly less than 2. Then if I can prove this one, then it will be 1 point something. Then the greatest integer, less than or equal to 3 power 1 by 50 will be 1 only. So now, 3 power 1 by 50 less than 2 is the truth of this one. So you assume again contrary to that. That is, assume that 3 power 1 by 50 is greater than or equal to 2. Now raise to the power of 50 on both sides. You get 3 is greater than or equal to 2 power 50, which is an absurd conclusion, which is impossible, which is not true, which is false. Therefore, you arrive at a contradiction. This contradiction is because of the assumption 3 power 1 by 50 greater than or equal to 2. It's a false assumption that you have made. Therefore, you got a contradiction. Therefore, 3 power 1 by 50 is less than 2. Correct. In a similar fashion, you argue in the case of 1 less than 3 power 1 by 50. That is, 3 power 1 by 50 is greater than 1 is required. So you assume that 3 power 1 by 50 is less than or equal to 1. Greater than 1 is required. So assume contrary. So you will assume that 3 power 1 by 50 is less than or equal to 1. Raised on both sides to the power of 50, you will get 3 less than or equal to 1 power 50, that is 1. So that is 3 less than or equal to 1, which is absurd, which is not possible, which is false. Therefore, you arrive at a contradiction. Therefore, 3 power 1 by 50 is not less than or equal to 1. Therefore, 3 power 1 by 50 is greater than 1. So, combining these two facts, that is 3 power 1 by 50 greater than 1 and 3 power 1 by 50 is less than 2. Combine these two, you will get 1 less than 3 power 1 by 50 less than 2. That means the answer to this 3 power 1 by 50 lies between 1 and 2. Between 1 and 2. Therefore, the greatest integer less than or equal to 3 power 1 by 50 is 1. So that's how you can argue and get this result. So in the examination hall, if you know this kind of arguments, that will be helpful. I am sure that you have understood the solution of the given problem on composition of functions from unit 1, and you have also understood how to get the bracket of 3 to the power of 1 by 50 is equal to 1 by 2 methods. I am sure that you have understood both the proof of solution of the given question and bracket 3 to the power of bracket of 3 power 1 by 50 is equal to 1. and I wish you all the best. Thank you.